Welcome to No Human Left Behind, AI the podcast. In today's episode, a conversation on robotics and embodied AI.
Welcome to your deep dive. We're going to be diving into the world of robots and AI, the stuff that's actually happening right now.
Right now, yeah.
You've sent us some fascinating material, and we're going to break down exactly how AI is being used to make robots that can, see, think, move, even work with us.
It really is an amazing blend of engineering, computer science, even psychology.
Wow.
Yeah, we'll be exploring the core concepts of robotics, how these machines perceive the world, the different types of robots out there.
Okay, so from the looks of it, a robot, it's not just any old machine, is it?
It's not. No, a robot is a programmable machine capable of carrying out a series of actions. So either autonomously or semi-autonomously.
So autonomously being
on its own completely, with a little help, semi-autonomously.
Got it.
So think of it this way. You need a physical body, sensors to understand its surroundings, actuators to move and interact, and then a control system, like a brain, to process information and make decisions.
So it's not just gears and metal.
No.
There's actual thinking.
There's thinking going on, yeah.
That's really interesting.
And just like humans, robots come in all shapes and sizes, each designed for specific tasks. So you have industrial robots, the workhorses in factories, doing things like welding and assembly.
Yeah, I've seen those big robotic arms.
Exactly. Then you have mobile robots used for exploration, surveillance, even transportation. And of course, humanoid robots built to resemble us and often used in research and service roles, like you might see them helping patients in hospitals.
I've always wondered about robot sight. I mean, it's not like they have eyes like ours. How do they actually perceive the world?
It's a good question. Robots rely on sensors to gather information about their surroundings. So cameras capture visual data, but they don't see the same way we do. It's computer vision to process the images, recognize things like traffic lights or pedestrians.
Right, so like a self-driving car.
Exactly, self-driving cars. Then you have LiDAR, using lasers to create a 3D map of the environment, which is really crucial for navigation. And for close-up detection, you have ultrasonic sensors. They work like sonar measuring distances.
LiDAR is what they use to scan those ancient artifacts to create those 3D models.
Yeah, exactly.
That's so cool.
It's all about capturing information and creating a representation of the world that the robot can understand. And that's where it gets really interesting, right? AI steps in, especially deep learning. These algorithms process that sensory data in real time, making sense of complex environments. It's how a robot can move through a crowded room without bumping into everything.
So the AI is essentially like the brain behind all this input from these senses.
Yeah, you can think of it that way.
But how does the robot actually move and interact?
That's where actuators come in. They're like the muscles converting energy into motion. You have electric motors for precision, you have hydraulic actuators for heavy lifting, and then pneumatic actuators for those quick, simple movements. So for example, those massive robotic arms you see in construction, that's hydraulics at work.
It's like a whole toolbox of muscles for different tasks.
Yeah, exactly.
But how is it all coordinated? I mean, it can't just be random flailing about.
No, definitely not.
Yeah.
Imagine a robot arm on an assembly line. There's individual actuator control for each joint, making sure the movements are smooth. Then there's trajectory planning. Figuring out the most efficient path, like when it needs to reach around an obstacle to pick up a part.
I see.
And then at the highest level, you have AI-powered decision-making, often using something called reinforcement learning. This is where it lets the robot learn from experience.
Oh, so it's like
figuring out the best grip for a specific object after a few tries.
It's like training a dog with treats.
Exactly.
If they do it right.
If they do it right, they get rewarded.
They learn to repeat the action.
Exactly. And this is where things get really, really exciting. Because we're not just programming robots with rigid instructions anymore. They're learning and adapting.
Yeah.
And that opens up so many possibilities for what they can do.
So, we've covered how they see and move. But how do robots navigate a complex world? How do they know where they are and where they need to go?
Right.
I mean, we have GPS.
We have GPS, yeah.
What do they use?
So that's where robot navigation and localization come in. And one of the most fascinating techniques is called SLAM, simultaneous localization and mapping. It's like a robot explorer charting new territory. So as it moves, it gathers sensor data, it builds a map of the area and keeps track of its location on that map.
At the same time.
all at the same time.
That's incredible. So it's like a built-in GPS and map maker.
Exactly. It's a lot of processing power.
That's wild.
And then there's obstacle avoidance. Imagine a robot navigating a busy warehouse. It uses its sensors, LiDAR cameras, to detect obstacles in real time. And then using path planning algorithms, it calculates a safe route, avoiding those obstacles. And AI is making a big difference here, too. Deep learning can be used to predict the movement of obstacles.
Oh,
so it's even
smarter.
Even more efficient path planning.
So they're not just reacting to what's right in front of them. They're anticipating and planning ahead.
Exactly.
Wow. But how does all of this connect with us humans?
Yeah.
How are we supposed to interact with these increasingly intelligent machines?
That's a great question. And that leads us to the world of human-robot interaction, or HRI.
Okay.
It's about designing robots that we can easily communicate with, understand and collaborate with.
So we can work with them.
Exactly. If we want robots to be partners in various tasks, we need to be able to talk to them.
Right.
Gesture, even have them understand our facial expressions.
Wait, robots reading our facial expressions? That sounds like a sci-fi movie.
It sounds like sci-fi, but it's a combination of technologies. Natural language processing, or NLP, lets them understand and respond to spoken or written commands, like the voice assistants we use every day.
Oh, yeah. Okay.
And then computer vision helps them recognize and interpret human gestures and those subtle facial expressions.
But it's like they're learning our language.
They're learning our language.
Verbal and nonverbal.
Both.
Yeah, it's crazy.
Yeah.
But can they really understand our intentions?
Well,
not just the words and gestures. Like if I reach for a coffee cup, can the robot anticipate that I want a refill?
That's one of the key challenges in HRI, moving beyond just recognizing the signals to understanding the meaning behind them. It's like a robot being able to tell if you're reaching for the cup because you want a refill or if you're just putting it away.
Wow, that's pretty incredible. It feels like we're on the verge of like this whole new era of interaction between humans and machines. But this brings up some important questions too, doesn't it? I mean, if robots are becoming so integrated into our lives, we need to make sure that they're safe and reliable.
Absolutely. Safety and reliability is paramount, especially as they become more capable and autonomous, and especially when they're working alongside humans or in critical situations.
Okay, so safety first. But what about responsibility? If a robot makes a mistake, who's to blame?
That's the big question.
The manufacturer, the programmer, the owner?
It's a complex question. And it requires careful consideration as we develop, the legal and ethical frameworks for a future with intelligent machines. Because as we're seeing, robots are quickly becoming more than just tools. They're evolving into collaborators, partners.
Right.
And that changes the whole dynamic of responsibility.
This is getting really, really interesting. So it's not just about the cool technology.
It's not just about the tech.
It's about the impact it has on society as a whole. But before we dive into those deeper implications, let's shift gears a bit and explore this synergy between robotics and AI that keeps coming up.
Yeah, let's do that.
In these sources.
It's a powerful synergy.
Yeah.
AI is playing a crucial role in pushing robotics forward, and robotics providing that real-world testing ground for AI algorithms to learn and evolve.
Okay, so let's delve a little deeper into that relationship.
Let's do it.
And how it's shaping the future of robotics.
Absolutely. It's like a dance. AI pushing robotics forward and robotics giving AI the stage to really kind of show off what it can do.
Yeah, high-tech tango. From what I'm seeing, AI seems to be like the brains behind the brawn.
Yeah, you got it.
Of robotics.
AI techniques like deep learning, reinforcement learning, computer vision, all of that is providing the intelligence that allows robots to perceive, to learn to adapt and make decisions in these complex environments. I mean, you could even say that AI is what's giving robots the ability to think.
So are we talking about robots that can actually think like humans?
Well, not exactly like humans, but AI is giving robots this level of cognitive ability that we once thought was impossible for machines.
Wow.
Like take deep learning, for example.
Oh.
It allows robots to learn these complex skills directly from raw sensory data, just like how our brains process information.
Right.
Instead of being programmed for every possible scenario, they can learn from vast amounts of data and adapt to new situations.
That's incredible. It's like they're constantly evolving and getting smarter.
Exactly. And reinforcement learning takes it a step further. It allows robots to learn through trial and error, which is incredibly useful for tasks like grasping objects or navigating tricky terrain.
So instead of being explicitly told what to do,
right,
they're learning by doing just like we do.
Just like humans do. Exactly.
That's really interesting.
And let's not forget computer vision, which gives robots the ability to see and understand their surroundings. Think about self-driving cars.
Yeah.
They use deep learning-based computer vision to recognize objects, estimate distances, and make split-second decisions.
Yeah, navigate safely.
To navigate safely. That's all AI.
So it's amazing how AI is transforming what robots can do. But you also mentioned that robots provide a testing ground for AI algorithms.
Yeah.
Can you talk a bit more about that?
Yeah, so robots provide that physical platform for AI algorithms to interact with the real world.
Okay.
It's one thing to develop a brilliant AI algorithm in a simulated environment, but it's a whole other thing to see it working in a dynamic, unpredictable, real-world setting.
Right. So it's a two-way street.
Is.
AI makes robots smarter. And robots help AI evolve by giving them real-world challenges.
You got it.
That's a really cool way to think about it.
Yeah, and this symbiotic relationship is driving this incredible innovation in both fields. Just look at the rapid progress we've seen in areas like surgical robotics.
Oh, yeah.
Where robots are now assisting surgeons with incredibly delicate procedures.
Yes.
I mean, think about a robot assisting with a delicate heart surgery. It's tiny instruments guided by the surgeon's hand. That's the level of precision we're talking about.
That's mind-blowing.
It's amazing.
It seems like the potential of AI is limitless.
Yeah, the possibilities are vast. But as with any powerful technology, we need to be mindful of the implications.
Right.
We've touched on the ethical aspects before.
Yeah.
And I think it's time to delve a bit deeper into those considerations.
Yes, let's explore that further. You mentioned safety and reliability.
Right.
But there's a bit more to it, isn't there?
There's a lot more to it. As robots become more integrated into our lives, we need to think about their impact on society as a whole. For example, if robots start performing tasks that were traditionally done by humans,
Right.
what happens to those jobs? How do we ensure a just and equitable transition for workers in those industries?
Those are important questions.
Yeah, it's not just about the technology itself. It's about how we use it
Right.
and how it shapes our world.
That's a much bigger picture.
Yeah, exactly. And then there's the question of bias.
Oh, okay.
AI algorithms are trained on massive data sets, and if those data sets contain biases, the AI systems themselves can become biased, leading to unfair or discriminatory outcomes.
So if a robot is trained on a data set that primarily features images of male doctors, for example, it might struggle to recognize a female doctor.
Exactly. That's a great example.
Wow.
We need to be very careful about the data we use to train AI systems.
Right.
And ensure that it's representative and unbiased. Otherwise, we risk perpetuating and even amplifying existing inequalities.
That's a really good point. This is fascinating, but it's also kind of daunting to think about all these complexities.
It is. It's a lot to consider.
Yeah.
But I think it's crucial that we have these conversations.
Right.
Technology is never neutral.
Yeah.
It reflects the values and intentions of those who create and use it.
So it's not just about building cool robots.
No.
It's about building a better future.
It is. And that requires thoughtful consideration of the ethical, the social, and the economic implications of these technologies.
Yeah.
We need to ensure that robots are used responsibly, that they benefit humanity as a whole, and that they contribute to a more just and equitable world.
Very well said. Okay, now that we've kind of delved into that ethical side of things,
Yeah.
I want to switch gears and talk about the different types of robots out there.
Let's do that. We've talked about industrial robots. We talked about those working in warehouses. But there's a whole spectrum of robotic applications, from healthcare to exploration.
You mentioned surgical robots earlier. Can you tell us more about those and some of the other exciting applications?
Yeah, surgical robots are really a prime example of how robotics and AI are transforming healthcare. They're allowing surgeons to perform these minimally invasive procedures with incredible precision, reducing patient trauma and recovery times.
It seems like robots are taking on roles that we never thought possible.
Absolutely. And it's not just surgery. Robots are being used in hospitals for all sorts of tasks, like delivering medications, disinfecting rooms,
Wow.
even providing companionship to patients. And outside of healthcare, we have robots exploring hazardous environments. I mean, from the depths of the ocean to the surface of Mars.
These robots are venturing into realms that are just too dangerous or challenging for us.
Exactly. And they're not just exploring, they're collecting data, conducting research, expanding our understanding of the world around us.
That's incredible.
Just think about the robots exploring the ocean floor, mapping the seabed, discovering new species. That's all thanks to robotics.
It seems like there's no limit to what robots can do.
Yeah, the possibilities are vast, and we're constantly pushing the boundaries of what's possible. You know, one of the most exciting areas is the development of soft robotics.
Soft robotics.
Yeah.
What is that?
It uses these flexible and compliant materials to create robots that can interact with their environment in a more gentle and adaptable way.
Can you give me some examples?
Yeah, so imagine robots inspired by the dexterity and flexibility of an octopus, capable of squeezing through tight spaces, manipulating delicate objects, or even providing assistive care with a human-like touch.
So that's quite a departure from the traditional image of robots.
It is. Soft robotics opens up this whole new realm of possibilities for robots to interact with the world in a more natural and intuitive way.
And what about the advances in AI? How are those shaping the future?
So AI is playing this crucial role in making robots more intelligent, adaptable, and autonomous. We can expect to see significant progress in areas like natural language processing, computer vision, machine learning, leading to robots that can understand our commands, perceive their surroundings with greater accuracy, and learn from their experiences more effectively.
So robots are becoming more like partners, less like tools?
Yeah, that's the long-term vision. A future where robots are seamlessly integrated into our lives, working alongside us, assisting us with our daily tasks, and even providing companionship.
That sounds like a truly transformative future. But I imagine there are still many challenges to overcome.
Yeah, creating robots that are truly robust, adaptable, and safe, capable of operating in complex and unstructured environments, that remains a significant challenge. And we still have a lot to learn about human-robot interaction, ensuring that robots can understand our intentions, respond to our needs, and interact with us in a way that feels natural and intuitive.
So it's about building trust and understanding between humans and machines.
Absolutely.
Shaping a future where they enhance our lives.
Yes.
Without replacing us.
Exactly.
That's a great point. This has been an incredible journey so far, exploring this world of robotics and AI.
It has.
I feel like we've only scratched the surface.
Just the beginning.
But it's clear that this technology is going to have a profound impact on our lives in the years to come.
It is, and I think the most exciting thing is that the future is still being written. We have the opportunity to shape it, to ensure that these technologies are used to create a world that's more sustainable and more fulfilling for all.
So for our listener out there, we leave you with this. What role do you envision robots playing in your life and in the future of humanity? What hopes and concerns do you have about this technological revolution? Keep exploring, keep questioning, and keep imagining the possibilities, because the future of embodied intelligence is in our hands.
Okay, so we've covered so much already, from how robots perceive the world to the, ethical considerations of their growing role in society.
It's been quite a journey.
Yeah, but I'm really intrigued by this whole embodied intelligence thing. What does that actually mean for the future of robotics?
It's a fascinating area of research.
Okay.
It really challenges us to rethink our understanding of intelligence itself.
Okay.
We're moving beyond this idea of robots as simple tools.
Right.
And towards a future where they're more like partners, collaborators, maybe even companions.
So we're not just talking about robots that can, think like humans.
Not exactly.
It's about understanding how having a physical presence, that embodiment, actually shapes intelligence.
Exactly. We humans aren't just brains floating in jars.
Right.
Our intelligence is deeply intertwined with our bodies.
Right.
Our senses, our interactions with the world.
Yeah.
And as we develop more sophisticated robots, we're starting to see how those physical experiences shape the way they learn and adapt.
Can you give me an example of how this embodiment plays out?
Sure. Think about a robot learning to walk.
Okay.
In a simulation, you can program it with perfect balance, coordination.
Right.
But in the real world, it has to deal with uneven surfaces, unexpected obstacles, even its own weight distribution.
Right.
Those physical challenges force it to adapt and develop a more nuanced understanding of movement and balance.
So it's not just about programming in the right way to walk.
No.
It has to learn through experience. Yeah.
Through its interaction with the physical world.
Exactly. And those experiences, those challenges, they actually shape the way the robot's intelligence develops.
Wow.
It's a fascinating feedback loop.
It is. This is making me think about those robots we saw earlier working in that disaster relief scenario. Navigating through rubble, climbing over obstacles, all while making decisions.
Yeah.
It seems like those physical challenges are key.
They are.
To their ability to function.
They are. And as we develop robots for more complex and nuanced tasks, things like elder care or working alongside humans in these dynamic environments, that embodied intelligence becomes even more crucial.
So what are some of the biggest challenges in developing this kind of embodied intelligence?
One of the biggest hurdles is robustness and adaptability. We can create robots that excel in controlled environments, but the real world is messy and unpredictable.
Right.
Think about the difference between a robot arm flawlessly assembling a car in a factory and that same arm needing to prepare a meal in a busy kitchen. Oh, wow. Yeah. So many variables.
So many variables,
Yeah.
exactly.
Yeah.
And it's not just about perception and movement, it's also about social intelligence.
Okay.
If robots are going to work alongside humans, they need to be able to understand our intentions, anticipate our needs, and respond appropriately.
In social situations.
Exactly. And that's incredibly complex.
Yeah.
It requires advances in fields like natural language processing, facial recognition,
Right.
even emotional intelligence.
It seems like we're talking about a whole new level of sophistication.
We are, and it's exciting.
Yeah.
But it's also important to remember that this technology is still in its early stages.
Right.
We have a lot to learn about how to create robots that are truly intelligent, adaptable,
Yeah.
and safe in the real world.
And as we develop this, we have to consider the ethical implications as well, right?
We do. It's not just about building cool robots. It's about building a future where robots enhance our lives, not replace us or create new problems.
Right.
We need to be thoughtful about how we design these systems, how we train them, and how we integrate them into society. So it's not just a technological challenge.
No.
It's a societal one as well.
Exactly. And it's a challenge that requires collaboration across so many disciplines. Engineers, computer scientists, psychologists, ethicists, policymakers, everyday citizens. We all have a role to play in shaping this future.
This has been an incredible deep dive
It has.
into the world of robotics and embodied AI.
It really has.
I feel like we've only scratched the surface, but it's so clear that this technology is going to have a huge impact on our lives
It is.
in the years to come.
And you know what I think the most exciting thing is?
Just that.
That the future is still being written. We have the opportunity to shape it, to ensure that these technologies are used to create a world that's, more sustainable,
Wow.
more fulfilling for all.
Well, that brings us to the end of our deep dive
Yeah.
into the world of robotics and embodied AI. It's been a fascinating journey exploring the incredible advancements and the profound implications of this transformative technology.
It has been.
As always, a huge thank you to you for sharing your expertise and insights.
It's been a pleasure.
And to our listeners for joining us on this deep dive. We hope you found it as thought-provoking and insightful as we did. Until next time, keep exploring, keep questioning, and keep imagining the possibilities because the future is in our hands.